Now, when you're doing long division, what do you do if there are missing terms? If you're missing a term, as in like x squared plus 6, then go ahead and write in the missing linear term. So just write x squared plus 0x plus 6. So for instance, if you needed to do x to the fourth plus 3x squared minus 1 divided by x squared plus 6, well, there's missing terms here. There's missing terms here. The way I think this should be set up is go ahead and include all the missing terms just with a 0 as coefficient. So x to the fourth plus 0x cubed plus 3x squared plus 0x minus 1 divided by x squared plus 0x plus 6. We won't do this particular problem. You should really try it on your own. Now, there's another thing that could be kind of messing with the problem. What do you do if the terms are out of order? So then just rearrange, right? So if you're asked to divide x cubed plus 2x minus 1 minus 2x squared by x minus 1, this seems odd because the terms are not in the order that we need, right? So just rewrite this. Instead, set up x cubed minus 2x squared, this term, then plus 2x, this term, then minus 1. So now this is in term order, x to the third, x to the second, x to the first, x to the 0th. Let's do this problem. We're going to do x cubed minus 2x squared plus 2x minus 1 divided by x minus 1 on the next slide. So the question is divide x cubed minus 2x squared plus 2x minus 1 by x minus 1. Okay, we'll set up the problem here. And again, don't look at all the terms, just the first term here, just the x cubed here, just the first term and the first term, and ask something times x is x cubed. Well, that something ought to be x squared. We'll just write it in the x squared column here. X squared times x minus 1, when you distribute, should be x cubed minus x squared. But since we need to subtract it, let's take x cubed minus x squared and distribute it in negative 1 so that we can talk about adding. So we have negative x cubed plus x squared. Now we can add in each column. We'll get x cubed plus negative x cubed is 0. And then negative 2x squared plus x squared is negative x squared. Bring down the 2x. Now ask the same style question. Something times just the first term here, x. So something times just this x here is just the first term here is negative x squared. And that something ought to be negative x. So negative x times positive x is negative x squared. Now think about negative x, distribute that to x minus 1, and you'll have negative x squared plus 1, but since we need to subtract, distribute in a negative 1 to negative x squared plus 1, and you'll have positive x squared minus x. So then you can add in each column. Negative x squared plus x squared is 0. 2x plus negative x is x, and then bring down the negative 1. Again, ask the same style question. Something to be placed here times just the first term here, x, is equal to just the first term here, x. So something times x is x. Well, that something ought to be a plus 1. So plus 1 times x minus 1 is x minus 1. But since we need to subtract eventually, let's distribute in that. Take that x minus 1 and distribute in a negative 1, and you have negative x plus 1. Now when we add, we'll get 0 here, and when we add negative 1 to plus 1, we'll get 0. So we actually end up with a remainder of 0. If we write this in the usual form, we'll have what was here, x cubed minus 2x squared plus 2x minus 1 divided by x minus 1 equals the quotient, which was x squared minus x plus 1, plus the remainder of 0 divided by x minus 1. Now hold on to this equation. We're going to come back to this in just a moment. The factor theorem. The factor theorem says a number, c, is a 0 of p if and only if x minus c is a factor of p. So let's do this quick question. So let p of x equal, it's actually the polynomial we just saw, x cubed minus 2x squared plus 2x minus 1. Let's show that p of 1 is equal to 0, and then use this to factor p of x. So first of all, taking this polynomial function, finding p of 1 is just, well, take what's here, replace every x with a 1. Use the appropriate language. Be consistent with the language. Take p of x. Don't just say, oh, don't we just plug it in for x? No, say plug in 1 for x in p of x equals x cubed minus 2x squared plus 2x minus 1. Then you'll have this is 1 cubed minus 2 times 1 squared plus 2 times 1 minus 1. That's going to simplify to 0. So cool, this shows that p of 1 is equal to 0. But because p of 1 equals 0, this number 1 that shows up right here, since 1 is an x value that causes the y value to be 0, then 1 is a 0. Remember that language is a little funky, but this x value here, c, is 1, and this c equals 1 is a 0. So 1 is a 0 of p, and then because that happens, this part happens here, the first part of the factor theorem. This is an if and only if. Therefore, x minus 1, same c, x minus 1 is a factor of p using the factor theorem. Now, since x minus 1 is a factor, we can actually figure out how to factor this polynomial x cubed minus 2x squared plus 2x minus 1. So earlier we had written down this equation. This is the long division problem that we just did. Now, actually, this 0 over whatever, 0 divided by anything, at least it's not a 0 in the denominator, but 0 divided by whatever, that term we can just get rid of. To simplify, we just not have this term. So we just wrote this equation down again, just missing the plus 0 over x minus 1. And now, the task here was to factor p of x. In other words, to factor x cubed minus 2x squared plus 2x minus 1, right, up there. So, to factor, well, take a look. We need this is equal to blah times blah. So look at this equation. Let's just not have a denominator. Multiply both sides by x minus 1 in parentheses, right? So we'll have the polynomial we want, p of x here. This is x cubed minus 2x squared plus 2x minus 1 is equal to what was here before, x squared minus x plus 1. That was the previous right side. Times, remember we just multiplied both sides by x minus 1. So this is x minus 1 here. So what we just did was we took this cubic, right, degree 3 thing, and we factored due to the factor theorem and the long division that we did. Now you give it a try. Interactive question. Let p of x equal x cubed minus 3x squared minus 10x plus 24. Now you ought to compute that p of 2 is equal to 0, but then use that information together with the factor theorem to completely factor this polynomial here.